Hello, my friends. We have different types of signals in Simulink with different usages. In order to know more about the signals in the Simulink, I go to Simscape library. Here we have SimPower system. Well, let me add some blocks to my new model. Okay, here I have three kinds of blocks from different libraries. About this transfer line, I should say that there are three outputs because out our transfer line is three-phase. Now I connect the first input to the constant block. As you can see, it is impossible. If I want to connect the constant block output to the transfer line input, as you can see, it is possible too. The reason is that there are specialized libraries in the Simulink. There are some blocks that can change the signals in order to connect them to each other. But these blocks may don't work well too. For example, this transfer line will transmit values like power. It has current and voltage in it, and we cannot connect a constant which includes a specific number in it. We can use SimPower blocks to connect this block. Also, we can use mechanical blocks for this body block, and this constant block is a general block, and we can use many blocks which we can use them. In any of Simulink libraries, you may face the same situation, and you should use some converters in those libraries. Let me show you a synchronic generator here. As you can see, this synchronic machine has both SimPower signals. There are three SimPower signals and three Simulink general signals that you can connect them to general blocks like constant, scope, and etc. By using this block, we can transfer the electric part, and for the general part, for example, we can specify its mechanical power by a constant number. For example, we can define its excitation voltage with a constant number. The M output is a synchronic generator data which we can show it with the mux block. So as you saw, there are some blocks which deals with both specialized and Simulink general signals. These blocks can be a suitable connector in those libraries that want to use them. The next library is signal attributes. Here you can see some blocks that you can use them in order to transfer the types of signals and switch them. For example, here we have data type conversion, which we talked about it in chapter 3. This block is used to convert types of signals. Usually this block has an input signal and an output signal. The input signal can be a real or complex number. If the input signals be a real number, the output will be real too. But if it be complex number, the output will be complex number. The only thing we can do is to change the output data by output data type. Here, the point is that we can see the data type from initial blocks. For example, here I want to show you again and constant. We can change data type of signal. Here, in any source blocks, and again there is an option named data attribute. You can specify the signal type from here. We can do so for gain 2. So generally you can change the signal data type. The other block here is data type duplicate. This block helps us in simulations in a way that specifies that whether two signals are same or not. For example, we have two input signals. If we enter the two signals and if we signals were not same, the system show an error. Let's give an example on this block. Suppose that we have a constant block which connects to 3 gain blocks. I use display block to display the output result. I set the constant block value 128 and set first gain block 2 to the power of 0 and second gain block value 2 to the power of 8 and set the third gain block 2 to the power of 16. As you can see, the display shows the data of inputs. Here 2 to the power of 0 is 1 and times to 128. You can see the result here. Here we have 2 to the power of 8. It multiplies to 128. And again 2 we have 2 to the power of 16 and times to 128. Now I want to change data type of blocks. In the first block, I accept the defined setting, and in the second block, I set the output data type unit 8, and the third block, I set the output data type unit 16, and then run the Simulink. As you can see in display 1 and 2, 0 is shown. The reason is that the output data, which is unit 8, cannot support input data. Now if I change it to double and change data output to unit 8, you can see the results. I want to use this block in order to see that are these two input signals same or not. As you can see, we have an error here. It means that the data types are not from one type. They are different. You can use this block in your different simulations and recognize data type by using this block. I save this model as data type. We have another blocks that you can use them in your special works, and you can know more about them with using Simulink help. Also, we have signal routing library, which relates to using signals. As you can see, we have mux, gmux, bus selector, and bus creator blocks here are here. I have explained them before, which are related to signals, and you can use these blocks when we have a lot of signals and we want to transfer them from one part to another part. The first block I want to explain is index vector. Index vector has switch mode, and you can define that which data port transfers to output with using the first input. For example, I set 2 inputs. Let me add some blocks. I add constant, display, I enter these values randomly. Okay, I run it. Now, as you can see, the third input was transferred to the output. If we enter 2, you can see that there is an error here, and it's because the number that we defined for the port 1 is not a logical number. So we should use 0 or 1. If we set the first input value 0, the second input of a block will be shown in the output that here is 12. And if we set it 1, the third input of block will be shown in the output that here is -25. You can use this index vector block in the form of switch in your simulation. The other block, which is very simple in manual, is manual switch. If you double click on the block, the switch transfers the second input, and then if you double click on the block again, it transfers the first input. It may have other applications in your simulations. For example, if you do control projects, as you know, we have PID and PI controllers. You can use these 2 controllers here, and with using this manual switch, select one of them. The other block is multiple switch. Like index vector, first port is a controlling port, and with using this port, we order to multiple switch that which of these 2, 3, or 4 ports display in the output. The other useful blocks about signals are from and go to. You can connect the go to block to a signal in your simulation and then recall it with from block. For example, here I recall PID controller. As you remember, we set a PID controller for a general system and saw the simulation outputs. Here I want to use these two blocks. I connect the go-to block to error signal that is here. By double clicking on the block, I can name it. I set it error. Then I can recall it in any part of the simulation by from block. Let me run the simulation. Now, as you can see, the scope recalls the error signal. For ensure, we can get copy from the block and see the related signal from here too. As you can see, the signals are the same. You can use this form and go to blocks to reduce the number of signals in the system. And these blocks are very applicative in very large systems. Here we have the port and subsystems library. It is related to next chapter about subsystems. What you can see here, that in, out, which are completely related to subsystems. When a signal enters to subsystem, we use in block, and when it exits from subsystem, we use out block. The Simulink will do that automatically, but we can enter or exit a signal from subsystems manually with these two blocks too. There are other specialized blocks which depends on the type of simulation. For example, we have trigger here which won't allow simulation if the signals hadn't been triggered, or it can change the output signal with that trigger. We have other blocks. For example, we have enable block here, like enable subsystems, and other blocks which are usually about subsystems.